Last night's homework. Again, you were supposed to draw the mapping showing one to the next, how they were mapping. And then you were asked, is it a function? And the other question with this that I always want you to think about that I'll ask you on the quiz and test is why? Why is it a function or why is it not? And again, you guys have the answers so that you should have been able to check these. And we will talk about it a little more upon my return as we look at these. As you look at lesson B2 in your notes. So in your textbook, if you were going to look, this is really lesson 4-6. It's saying that you can explain the function notation, not just the f. You can decode the notation and explain what the rule means. You can evaluate it for a given domains, where you can continue talking about domain, and you can identify if the numbers are in the domain of the function. You can choose a domain that makes sense for that situation. You're going to be asked to create a graph and then determine the description and explain how the domain is represented in that situation. So as we are taking a look at this situation, a relation. What is a relation? Not a relationship. A relation is a relationship between the two variables. As you're filling in your notes, a function is a relation which each input has exactly one output. And this is where tonight in your homework, I am going to ask you for the why. Why is it a function? So yesterday we talked about that vertical line test, that if it passes a vertical line test, it's going to be a function. Today we're going to be looking at this other rule. For each input has one output. What is the domain? That's all our input values. And the range is going to be all of our output values. And again, if we're thinking about this, what do we really mean for our input? Usually that's our x value. So when you're thinking about domain and you think about an ordered pair, that is your x values. And so when you're thinking of this ordered pair, x, y, this is usually, when we think of in mathematics, our domain is our x, and the y is going to be our range. And it's all the possible numbers that we can have for our y's and x's. So first thing you ask us, determine if it's a function. Now, as you're looking at these, I want you to think tonight in your homework, why. Okay? So we're going to give a why reason for each one of these. So as we take a look at this, negative 2, 7, negative 1, 5, 0, 3, 1, 1, and 2. Does each input have one output? So is this one a function? We would say, yes, it is a function. Why? Each input has one output. Okay? So that's what we're kind of thinking about. Now, if we look at the one below this, notice negative 2 has negative 7 and 5. 2 has 0 and 6. So this one, not a function. And if I was asking you why, you could tell me the reason why is because negative 2 and 2 have two outputs. So they both have that same output. Now the question that sometimes comes up is, oh, well, could I have, if I am looking at my different values, can I have all of my points be the same in either the x or y? And we'll talk about that. When is it a function? So if we're looking at this one, does each input have one output? Please check with your shoulder partner for this one and the one below. And you're going to see I'm going to put the answers up in just a minute. So please check with them. If you want to pause the video and kind of talk about it, you can do so. And we should be looking at the first one is a function, the second one, not a function. What are our reasons? Here, each input, that's the easiest reason you can always put down, has one output. That is our definition of a function. And here, if we notice negative 4 has two outputs, we could see at 2 it has two outputs. You could also say it does not pass that vertical line test, if I could draw a vertical line. So not a function. Two reasons. Doesn't pass the vertical line test. So we could put that down. It doesn't pass the vertical line test. And the output, input of negative 4 and negative 2 have two outputs. So because we can only have one output for each input. So the input of -2 and 4, -4, and over here when we are looking at -2, and it doesn't matter any of these points in between here have two outputs. There are 2 points on our graph. So what is function notation? This function notation is, instead of writing an equation in y equals -3x plus 1, we are going to say it's a function. So f of x is how we read that. F of x is equal to -3x plus 1. The letter f is the name of the function. It's not a variable. Function notation is used to emphasize that the function value f of x depends on the independent variable x. The other letters besides f that are sometimes used might be g and h, so you'll see those written in different ways. So here they use w. The function w of x equals 250x, and it represents the number of words. So that because we're talking about words, the words x you can read in x minutes. How many words can you read in 8 minutes? Well, if we're writing this in function notation, this is what we're going to look at. We're going to start with w of x equals 250, because we're reading that equation, 250 words, it looks like, per minute. We're trying to find 8. So we're going to replace x with 8. In our equation, replace 8. 250 times 8 would give us 2,000. If we were writing it not in function notation, and this is kind of our linear equation, y equals 250x, we would have still got the same answer. We are now going to take a look at this video. As you watch this video, I'm only going to look at a certain part of it, and it kind of explains what we are talking about here.
Coordinate is the x value, and the second coordinate is the y value. If a set of values is a function, its relationship can be shown with function notation. Function notation represents a rule that relates the domain of an equation to its range. Function notation is y equals f of x, where x is the domain and f of x is the range. Now let's look at the relation where y equals x plus 1. Since every x value relates to one specific y value, this relation is a function, so y equals f of x. Now let's look at
Notice the notation.
F of x equals x plus 1. F of x represents the y values. On a coordinate plane, the domain is on the x-axis. F of x is on the y-axis.
So domain and range.
X equals -1, y is 0. When x is 0, y is 1. And when x is 1, y is 2. This relation is a function because every x value relates to one exact y value, so y equals f of x. Let's take a look at another function. In this table, the domain is 0, 1, and 2, and the range is 1, 2, and 3. The function for this table of values is f of x equals x plus 1. When x is 0, f of 0 is 1. When x is 1, f of 1 is 2. When x is 2, f of 2 is 3. In a function, the y values represent f of x. This table of values is a function because every x value is related to one exact y value. Now let's go back to the opening question. Molly earns $16.
So as we look at that next page of your notes, we are going to be thinking about, given this function, find what each of these values are. So we read this as what is g of 4? If we're going to find g of 4, we're going to replace up here in this equation. So we're going to go here and we're going to put 2 times, we're going to replace the x with a 4 minus 4. 2 times 4 is 8. 8 minus 4 gives us the final solution of g of 4 equals 4. What is h of 4? Well, the equation for h is that x squared. So instead of x, in this equation, as we look at that, we are putting in x squared. So we're going to put in 4 squared minus 4 times 4. Well, 4 squared is 16, minus 4 times 4 is minus 16. That gives us a solution of h of 4 equaling 0. What is h of -3? Again, going back to this equation, our rule says take x and square it. It's really important now that you square the negative. Put it in a parenthesis, and when you put it in your calculator, it's important you put it in a parenthesis. Minus 4 times negative 3. If you do not put this in your parentheses, this would come out to be negative 9. And actually, negative 3 times negative 3 is not negative. It is positive 9. We have a minus, and it's going to be a negative 12. Well, minus a negative 12 is plus. So if we are looking at that solution, 9 plus 12 would give us g of negative 3 equaling 21. In our last one, g of negative 5, or h of negative 3, excuse me, g of negative 5. So I'm going to go to my equation. It was 2 times. Instead of x, I'm plugging in negative 5 minus 4. 2 times negative 5 gives me a negative 10 minus 4 equals negative 14. How do I write my answer? I write g of negative 5 equals negative 14. You do not just tell me negative 14. You want to write this whole work with the function equaling the number. Okay? So if you need to pause it to make sure everyone has this written down, do so. And as we go to this next page, we're going to be talking about what's a reasonable domain and reasonable range. So you have 3 quarts of paint to trim your house. 1 quart covers 100 square feet. The situation is a function, so we know that. This is the model. A, standing for area of the quart, Q, is equal to 100, because it covers 100 square feet, Q. So it says to find a reasonable domain and range of the function. A reasonable domain is the set of all inputs that will work. Well, we can't have 0 quarts, but we can have greater than 0, right? It can't be negative. If we're thinking about values for quarts, can it be 1,000? Well, no, they tell us we only have 3. So what can it be? Can we use a fraction of our quart? Yes, fractions and decimals. What's a reasonable range? That means our output values that will work for this function. Meaning, can the area be negative? No. Can the area be 1,000? Well, we got to think about how many quarts we have. Could it be a fraction? Well, that's possible, depending as we're multiplying by 100. And if we're going to use our domain and range. So what I want you to do is I'm going to show you this answer. There's a lot of writing here. So you can write your answer in a sentence or an inequality. And you're going to see this solution. And I was going to write my writing out, but my writing sometimes is something is hard to read. So I am going to look at the solution that they have written down, because I think you're going to be able to read this a little better. And so when you look at this, I'm going to have you pause the video so that you can all write this down in that box. Here's the key features. The least amount of paint is 0, which means the domain can go from 0, but you only have 3. So when we talk about our domain, the domain is going to be from 0 to 3. Since we only have 3 quarts of paint, and each one covers 100 feet, that means that we can only use 0 times 100, which give us a range of 0. And if we are looking at the most area it's going to cover, it's 300. So we're going to talk about, as we look at this, the other thing that a lot of times you're going to see is that they'll say that this domain is for all real numbers. Why for all real numbers? Same thing here. Because can we have a fraction or a decimal of a quart? Could I use 1.5 quarts or 2.75 quarts? We could. So it's inclusive, but it's really for all real numbers, because you can have a decimal or a fraction. So that's kind of important. Again, if you didn't get all that down, pause the video. Again, this will be on the daily planner, so you can watch it again, but make sure you have your notes filled in. Now, it says you go to a kennel, charges $15 a day to board your dog. Upon arrival, the dog must have a flea bath, and it costs you $12 for the flea bath. You may not board a dog for longer than 3 weeks. Write a function for the total cost for boarding N days. Now, the first thing you have to think about is, okay, 3 weeks. You can go up to 3 weeks, which means how many days? Well, 7 days in a week, so you could go at most 21 days. So that's kind of important that you make sure you understand that. What's the least you could have? You could have 1 to 21 days, right? I mean, if you go there, you're going to have to stay at least 1 night. So the question is, as we are looking at this, what could be our function? And we're going to say cost of staying for the days, C of n. N is going to be our days. It's going to cost me $12 no matter what for the flea bag. Plus, each day I'm staying for my dog, I have to pay $15 a day. So this is my equation. We want to think what's a reasonable domain. Well, how many days can we stay? You can say a day, a half a day. Does it matter if you say a half a day? You still have to pay 15. You do. So when we think about the domain, we're going to say any whole number, right? Because it can't be real, it can't have a fraction or decimal. Any whole number, and when we think about it being a whole number, we're going to say from 1 to 21. Now, we usually aren't going to write it this way. We're going to say, what is our value of n? Could we say 21 days? We could. Can we say 1 day? Yes, so we could have greater or equal to 1. So my domain for this one is going to be that I'm looking at domain between 1 and 21. Now we want to think of what is our range. When we look at our range is going to be, as we are looking at this, again, whole numbers. So we're thinking of our costs. They are charging us exactly this. There's no fractions or decimals. It's going to be a whole number. And if we are looking at 1 day, so if you plug in 1 here, 15 plus 12, we are talking about our minimum being $27. Is less or equal to, we're going to put the function C of n, and what's the most they can charge us? Well, now we say 21 days. So you want to plug in 21 for n. So if n is equal to 21, 21 times 15 plus 12, we would be up to $327. A lot to board your dog. But we all do that because we love our dogs and sometimes we need a break. All right, so it says draw a graph of this. Now again, when you look at this graph, as you look at the graph, I'm going to have you just copy this. And I want you to think of and it says our time here, and it should be, if we are looking at this, for our cost of dogs, and this should be not in hours, but if we are looking at this, this should be days. Here's what we have for a graph. Now, before you copy this graph down, I want you to think about something. Can we have a fraction of a day or a time if we are looking at this? So please make sure you change time down here to be days. And then the next thing we were thinking about is, can I have a fraction of a day? And so really, do not make a line. Put dots all the way along here. Why? This is a discrete, it's called discrete graph. It is not continuous. You pay 1 day and each day it goes up by a cost of 15. So please make sure you put points and not a straight line for that one. Again, if you need to pause the video, we know this point right here is at 21,327. This point here is at 0, and if we would have put in 0, we would be at 12. So that's where this point is, if that helps you. Again, pause it before we take a look at the next couple examples. In your homework tonight, you're going to have quite a few situations, and that's on the last page of the worksheet that you're going to, in your workbook that you're going to be looking at, or that worksheet. And here it says a 10th grade class is selling granola bars for a fundraiser. 75 cents a granola bar. Here's our function. The profit of each bar is 75 cents. That represents profit they earn from selling each bar. Find a reasonable domain and range. So I want you to try this right now on your own. Domain and range. What kind of numbers? Here's a nice way of putting it when we think of our domain and range. I'm going to say, what are the amount of bars we can have? And when we look at our range, we're talking about the profit. How much profit could we make? What is it between? Now notice I have less or equal. What's the least if we sell 0 bars? Yes. I know some of you are thinking it, 0. Which if you don't sell any bars, you don't make any profit either. I now want you to look at the most we can make and fill in these two. And if you need to pause it, please pause it so you can think about this. We should have the most bars we can sell. is 300. That goes here. If I take 300 times 75 cents, I'm going to end up, the most profit I can make is 225. We want to look at the graph. As you look at the graph of this again, as I look at this graph, should it be continuous or discrete? Can you sell people half a granola bar? Or can they buy only a half or a fourth? So again, what I don't like about this graph is the graph should be discrete. So that when I look at this, I can see 0, 0, and then please, please, please do not draw a line on yours, put points, right? Our top that we can sell is at 300 bars, and the cost is $225. The least we have is at 0 bars sold, $0 profit. This should definitely be a discrete graph. No line. You cannot sell people half a granola bar. Now, as I look at this last part, we're looking at a car traveling 32 miles per gallon. Here's our function. So we are asked for the domain and the range. We will practice more of this next week as we look at this. So our domain is our x. X, it tells us, is the gallons. Our range is d of x. What is the amount of gallons of gas that we have? Well, we have 17 in our car. That means domain goes from 0 to 17. This is our gallons. What's the range? So this is our gallons. That's our x. This is the number of miles that we can drive. And we can drive 32 for each gallon. So 0 is our least. And the most we can drive is taking 32 times 17, which does give us 544. And in this case, we would be talking about, those are our miles. Now, this graph, I finally like how this one was done in our notes. This one is a continuous graph. If we are looking at our points, this point up here is located at 17 and 544. This point is at 0, 0. So please make sure this is a continuous graph. Why is this one continuous? Because you can buy a decimal or a fraction of a gallon of gas. You can buy 1.2 gallons. Your homework. You are looking at each one of these problems, and as you do the problem, you are trying to figure out how many words is W of 9. What is D of 8? In this one, domain and range. Remember, domain simply means substitute this value in for x. Tell what your y is, or in this case, your f of x. That's your range. So x, and this is your f of x. Be really careful here when you square the numbers, okay? Be careful here when you cube a number. Make sure you know those. And then here, you're asked to find that number, okay? In this question, you're going to use the equation, but now what you're going to do in this one is you're going to put 46, because we're looking at f of 7, or f of what? F of question mark is equal to 46, and our f equation was x squared minus 3 is equal to 46. So you should be able to solve that. Again, reasonable domain and range. Look at your notes. If you're really struggling with this, make sure you go back and put in domain and range and watch another video or watch this video again. You should have this completed upon for tomorrow's class, so make sure you're ready.